So we know that C of x is always below f bar of x. So actually, let me write that more precisely. We know that C of x is less than or equal to f bar of x. In other words, C of x always resides below f bar of x. Furthermore, we know that the distance from f of x to the end of the interval, this distance is at most p of x over 2. So we know that if I take an interval from c of x to c of x plus p of x over 2, it must reside entirely on the same interval as f bar of x. So everything boils down to f bar of x here. I start with f bar of x. I guarantee that my representation is somewhere below f bar of x. So my representation, what I do is I truncate the binary representation. So I guarantee that that's somewhere below f bar of x on the same interval. Finally, what I do is I show that there's no other code word within a certain range that is on the same interval. So therefore, this must be a prefix code. So the average length of such a code. Well, I know that L of x is ceiling log 1 over p of x plus 1. And that's true for every code word. So the average length of the code is the sum over x, probability of x, times L of x, which is sum over x, probability of x, ceiling log 1 over p of x, plus 1. Now, once again, I'm going to get rid of the ceiling function. So when I get rid of the ceiling function, that must be less than or equal. Wait. When I get rid of the ceiling,
Isn't it every code has same length?
What do you mean?
All code word has the LX for their length.
All code word has L of x given by this.
Mm-hmm.
So
Just depending on the probability.
that's right. It's dependent on the probability, so not all of them will have the same length.
What's wrong?
I want this to be.
It's going to be less than.
Is it going to be less than? If I get rid
So
of the ceiling.
the left side should be greater than. Sorry? Right, because you're going to have a smaller number that you're multiplying with an always positive number.
Right, so this is always positive. Wait.
So the if you get rid of the ceiling,
Yes.
the right side should be, less than the left side.
Right, I should have this, but that's not what I have here.
I would think.
Oh, I know, sorry. Yeah, so what we have is, okay, here it is. We have that ceiling X is greater than X,
Yeah.
but less than X plus 1. That's what I want. Sorry about that. I just had a little brain freeze there.
Oh, so you don't add the 1 on the left side of the equation?
That's right, so I didn't realize that wasn't in my notes. Okay, so this is less than or equal to some X, P of X. If I get rid of the ceiling, on the right here I have log 1 over P of X
Plus 2.
plus 1 plus 1, which is 2.
Okay.
There we go. Which is equal to, okay, sum over X, P of X log 1 over P of X is entropy plus 2. So, the average length of the Shannon-Fano-Elias code is no more than entropy plus 2 bits. So now we're basically losing a bit, but in exchange for that we get a very nice code. So remember the maximum penalty of the optimal prefix code was 1 bit. So now we have a 2-bit penalty, but that's okay because we have a nice code. Okay, let's look at some examples.